In section 2.1, we're going to look at frequency distributions and their graphs. A frequency distribution is a table that shows the classes in intervals of data entries with a count of the number of entries in each class. The number of entries in a class is called the frequency of the class. Each class will have a lower limit, which is the smallest number a value can have to be a member of a class, and also an upper limit, which is the largest value a member can have to be an element in a class. Typically what we're trying to do here is we're trying to, and this is true for all of chapter 2, is we're trying to take our raw data sets, which would just be pages and pages, or just a collection of raw data and just numbers on a page. And the ultimate goal is to kind of take that information and sort it and organize it in a way that makes it more readable, easier to understand, and also kind of help spot patterns and trends. Okay. Let's look at the following situation. Let's suppose we look at a bunch of class averages for a section of Math 120. And let's suppose that we have a range that went from a smallest value of 42, was the lowest average in the class, to a maximum value of 91 in the class. We could organize this into classes. The first class is from 42 to 51. 42 would be the first lower class limit. 51 would be the first upper class limit. And this would have a frequency of 3, meaning that there was 3 students that had averages between 42 and 51 inclusive. The second class has a lower limit of 52 and an upper limit of 61, and it would have a frequency of 5. If we kind of look at all of the data from this, so the lower class limits would be these values here, the 42, 52, 62, 72, 82. The upper class limits would be 51, 61, 71, 81, and 91. One of the things that's going to be consistent when it comes to our classes is how wide they are. So a very important calculation we're going to have to do in section 2.1 is the ability to calculate class width. Class width is defined as either the difference between successive lower class limits or successive upper class limits. So for example, if I look at the first 2 classes, this one has a lower class limit of 52, this one has a lower class limit of 42. If I do 52 minus 42, that would give us 10. I could have picked any 2 consecutive lower class limits. For example, if I look at these 2 here, 72 minus the preceding one of 62 would also give us 10. Conversely, if I were to pick any 2 upper class limits that are consecutive, 71 minus 61 also produces that class width of 10. So this is something that's going to be very important, especially in 2.1, is that the class width is the difference either between successive lower class limits or successive upper class limits. A lot of students will make the mistake of trying to take an upper limit minus a lower limit and thinking that gives the class width when in fact it does not. For example, if I try to do 51 minus 42, that would give us 9, when in fact the class width should be 10 on this. So be very careful with that. Let's take a look at an example together. Suppose we are asked to build a frequency distribution for 30 individuals. So we have these 30 values all together to describe how much time they spent on their cell phone each month. So we have this raw data set. One of the things that's going to be very helpful to us, and something we're going to do throughout the class, is the concept of data entry. So if I pull up my either TI-83 or 84, whichever one you have, what we want to do is first of all know how to enter this data into the calculator. And both the TI-83 and 84 have a button. It's right here on the second row on the top, kind of in the main body of the calculator, that's called Stat. I'm going to hit the Stat button, and then we have the option to edit, which is to edit and to input our data set. So I'm going to go ahead and I'm going to hit edit and enter, and now this will give me an opportunity to enter my values. I'll enter them going horizontally. The first number we have is 102. I'm then going to hit enter to jump down to the next entry. The next number is 124. I could hit enter again, or you can even use the cursor arrow down to continue. Next one is 108, 86, 103, and then 82. It's very important to understand that all of this data belongs to one data set. So even if it's arranged in, let's say, like rows or columns, this is one complete data set. So when we're inputting one data set into our calculator, we'll try to keep it under the L1 column. That's the L1 list for data. All of these values have to fall under that very same list. So I'm just going to come down to my second row and just keep on entering. 71, 104, 112, 118, 87, 95, and now I'm going to make my way down to the third row. Okay. I'll pause the video just so I can get these entered, and then we'll pick up from there. Okay, so we now have all of our values entered. Notice that in the beginning of this example, they said that there was 30 people altogether. And so we have a list of 30 times for how much people spend on their cell phone. If I look at my list, one of the things that you'll see, according to next entry, is I see L1. First of all, that's the name of the list. That's where I'm storing all of my information. And I see that my last entry, which was that number 92, is located in the location where it has a 30 in parentheses. That tells me that that was the 30th entry in my list. And so that should kind of match up and make sure that I have inputted everything properly, making sure I didn't accidentally miss a value, or perhaps, accidentally maybe put a number in twice. So if that matches up, that's a good indicator that perhaps we have the data entered correctly. Now the next thing we're going to do that's going to be very helpful is we want to sort this set. So what we're going to do is now try to sort the data set. And the way that we do that is you can go to the Stat button again. So we're going to hit Stat. We have already gone under the Edit menu, but directly below that we have two options. There's Sort A, which stands for Sort Ascending, which would mean from smallest to largest. We also have Sort Descending, which would sort from largest to smallest. Usually I tend to find that Sort Ascending kind of works the best, starting out small and working our way up. So I'm going to sort this list in ascending order. So I hit Enter to put the Sort Ascending command on the home screen. And now what I need to do is tell the calculator which list, because you could be using more than one list, but which particular list I'm hoping to sort. And we wanted to sort the L1 list. You can put the L1 inside the sort option by doing a couple different things. First thing you could do is if you look directly above the number 1 key in blue, we see the name L1 for list L1. Because it's a blue key, I would need to hit the second function and then 1, and that's one way to get L1 in that grouping symbol. And that's always proper that if you have a left parenthesis, you should also put a right parenthesis. Another way in which we could get the L1 into this thing is if you look directly above our Stat button. So directly above Stat, the blue key says List. I can hit Second List and then go to L1, and that would also put the L1 into the list. Now that we have the L1 list under our sort option, we can just simply hit Enter, and the sorting is now already done for us. It doesn't look like it did a whole lot. It just says Done. But if we go back into our Edit menu, if I go back to Stat, if I hit Edit, one thing we'll notice is that all 30 of the values we entered are still there, but now they've been sorted into ascending order from smallest to largest. Okay. Another way in which we can actually look at the list that's been sorted is if we simply go back to the home screen. If I put the L1 list on the home page by doing, again, second 1, or by navigating through the Stat menu, and then you get the L1 name on there, hit Enter, what that will do is it'll display our list horizontally, and you can use the left and right cursor to kind of scroll through and look at the list. This is going to be extremely helpful, especially once we try to do our frequency distribution by hand. Okay. For this particular problem, we want to construct the frequency distribution, and we're going to use a total of 5 classes altogether. Okay. In order to find the class width, this is going to be very important. The formula for class width is max minus min divided by the number of classes. So they will always kind of tell us, how many classes to use. This isn't something you have to calculate on your own. If I look at the data set, So I'm going to go stat, edit. We see that the smallest class value is 67. That's the minimum. The largest value is 125. So if I do max minus min, 125 minus 67, I hit enter. That's the difference between high and low. We sometimes call that the range. And I'm going to divide that by the number of classes. They tell us for this problem we're going to be using 5 classes. So divided by 5, I hit enter. And we get a value like 11.6. Okay, this is very, very, very important. When it comes to rounding the class width will always be a whole number, and we always round up when you get any decimal value. So 11.6, luckily for us, naturally that would always round to 12 no matter what. But even if we had got something like, let's say 11.1 or 11.2, class width always gets rounded up to the next integer. Okay. So that's how we can use the calculator to kind of sort things, help us out a little bit. And now that we have the class width, we're ready to fill in our classes. For us, we're always going to start at the minimum. So our first lower class limit is going to be 67. The next thing we can do is find our remaining lower class limits by simply adding that class width of 12. 67 plus 12 would give us 79. 79 plus 12 gives us 91. 91 plus 12 gives us 103. And then 103 plus 12 would give us 115. We would now need to find the corresponding upper class limits. And in order to find the first upper class limit, we can do somewhat of a reverse lookup. We already know that the second class is going to start at 79, which means that the previous class must have ended before that, meaning the first upper class limit has to be 78. And then once you have that first upper class limit, you can simply just add the class width to go down. Plus 12 gives us 90, plus 12, 102, another 12 is 114, and then add 12 again, we get 126. So these are our classes. With our list sorted, this is going to be a huge help in terms of calculating the frequencies. If I go to my list, second L1, the first class goes from 67 to 78. So anytime we have a value that falls in that range inclusively, we count it up. So 67 is in there, 71 is in there, as 2 is 78. Now 82 would be too much. That's going to be into the second class. So altogether we have 1, 2, 3 values that are in class 1. Let's now look at the second class together. Between 79 and 90, the first one that's going to meet that criteria is going to be 82. That fits inside of there. So we're going to have 1, 2, 3, 4, 5, and now 92 is too much. So the second class is going to have a frequency of 5. You can repeat this going through the rest of the data set. There's 8 numbers that fall between 91 and 102. There are 9 values between 103 and 114. And there were going to be 5 values between 115 and 126. An easy thing to do to check to make sure we're on the right track is whenever you sum up the frequencies of all of the classes, it should work out to be the same as the size of your data set. If I check and do 3 plus 5 plus 8 plus 9 plus 5, we get a sum of 30, which is exactly how many values we had. To sum up, sometimes you'll see this a lot later on in the class, but we use the Greek letter capital sigma as the symbol for the total or the sum. So it does add up to 30, and that's good evidence to support that we didn't miss any or we didn't accidentally double count anything. So that's the very first important thing we're going to use is the class frequency. The next thing we want to do is find the midpoint of a class. The midpoint is simply the value that's halfway between the lower class limit and the upper class limit. And to find the class midpoint, you just do lower limit plus upper limit divided by 2. For example, I'll do the first one in the calculator together. If I'm going to do 67 plus 78, divide that by 2, according to order of operations, I need to put a parenthesis first around the addition to save the division for last. And that's going to give us 72.5. For the next class midpoint, you would do, again, lower plus upper divided by 2. 79 plus 90 divided by 2 is 84.5. For the third class midpoint, you have 91 plus 102 divided by 2. That's 96.5. But you might, at this point, kind of see a pattern that's happening here. Once you have the first class midpoint, to get the remaining class midpoints, really all you would need to do is add that class width to go down. For example, 72.5 plus 12, that would give us 84.5. 84.5 plus another 12 would give us 96.5. 96.5 plus another 12 would give us 108.5, etc. And that's kind of a little bit of a faster approach. Just find the first midpoint by using the formula, and then you can always add the class width to go down. The next thing we're going to come up with is the relative frequency. The relative frequency gives us the percent or the proportion of users within each frequency relative to the data set. Whenever I explain this in class, I always like to kind of give the example in class where I'll phrase it like this. Suppose you have a course, let's suppose it's a mathematics course, where 30 students in the class get an A. The question I always ask is, did the students in that class do well? And so a lot of students will think about it for a moment. Usually my class sizes physically are between, 28 to 33 people. So if you're talking, 30 people out of, 33 or so, that's a really good performance. But let's suppose that if I'm looking at it across all sections, and let's suppose that I had 30 A's out of 1,000 students, then that would represent only 3% of the population actually getting an A, which wouldn't look so good. And what that kind of illustrates is the fact that sometimes just frequencies and counts by themselves don't really give a true sense of the magnitude or the relative value of that count. Oftentimes we need to compare the part to the whole, and that's really what the relative frequency does for us. Okay? To find the relative frequency of a class, you just take the frequency of the class and divide it by the size of your data set. So divide it by the total number of numbers. For the first one, it would be 3 divided by 30. That would give us 0.10. For the next class, it's going to be 5 divided by 30, which we're going to round a little bit. This is going to round to 0.17. For us, relative frequency, we will always round it to 2 decimal places. The next one would be 8 divided by 30. That's 0.27. 9 divided by 30 is 0.30 rounded. And then 5 divided by 30 would be 0.17. Theoretically, if we didn't round any of these at all, the relative frequencies would always add up to exactly 1. However, in this case, due to a little bit of rounding, the added values will be close to 1, but not exactly on the dot. But theoretically, relative frequencies should always sum to 1. The last thing we're going to look at is the cumulative frequency. The cumulative frequency of a class describes the number of values in that class, plus all of the classes that come before to precede the class. To start computing the cumulative frequency, we note that the cumulative frequency of the first class is just going to be the same as its frequency. So this first class has a frequency of 3, therefore it's going to have a cumulative frequency of 3. For the second class, it has 5 values in it, plus the 3 that come before it. 5 plus 3 would give us 8. For the third class has 8 numbers, plus the 5 before that, plus the 3 before that. 8 plus 5 plus 3 would give us 16. For the fourth cumulative frequency, we have 9 in this class, plus the 8 plus the 5 plus the 3 that come before it. 9 plus 8 plus 5 plus 3, that will give us 25, and you just kind of continue as you go down the list. An alternative and a slightly faster way to doing this, for example, if I kind of pick on the cumulative frequency for class 3. By definition, the cumulative frequency of class 3 should be the number of values in that class plus all of the classes that come before it. Well, that can simply be found by taking that class frequency and adding to it the cumulative frequency of the previous class. If I do 8 plus 8, that gives us 16. For the second to last class, I can do its frequency of 9 plus the previous cumulative of 16. 9 plus 16 gives us 25. And then for the last cumulative frequency, its frequency is 5, plus the previous cumulative is 25. 5 plus 25 gives us 30. And this is a hallmark of cumulative frequency in that the very first cumulative frequency is the same as the frequency of the first class, and the very last cumulative frequency is equal to the sum and the total in your data set.